Hey, it's Dr. J. So our lecture on 5.2 got cut off a little early. So this is the second part of 5.2, place value systems. Today we're going to learn about the Babylonian numerals, or the Babylonian number system. The Babylonian numbers. This is Babylon, 600 BCE. The Babylonian Empire. It stretched from the Persian Gulf all the way to the Mediterranean Sea, covering a huge area which now is parts of Syria, Iran, and Iraq. The Babylonian number system is a base 60 number system with 59 different symbols. Imagine growing up in Babylon. Little kids had to learn 59 different symbols. We only have to learn 9, or 10 if you count 0. Notice there is no symbol. My pen is really sloppy today. No symbol for 0. I don't know what's going on with my pen today. So there is no symbol for 0. They only had the whole number, the natural numbers, no zeros. Look at these strange looking symbols. Why do you suppose they look like that? Well, it's because of the tool they used. It's called a stylus, and it was made of a palm reed. And so this is a clay tablet. The first iPad. And they would press the tip of the stylus into the clay, making the shape. The Babylonian numerals are a base 60 system, and they read them from right to left. So the first symbol that they would make, this is the symbol for 11. They would essentially press in the stylus once here, and then they'd press it in twice here, and that would make what they would call 11. Now, as they move from left to right, it becomes a multiple of a power of 60. So they leave a blank space, and then they press in the next set of symbols. This is the symbol for 21. Again, you don't have to memorize these. I'll give you the chart as a reference. The symbol for 21, the main thing to keep in mind is this doesn't actually mean 21. It means 21 times 60. Then they leave another blank space. They get to the last symbol. This is probably the easiest symbol. It's just 1. Just press the stylus into the clay one time. And again, as you're reading from right to left, each symbol is a multiple of a power of 60. So the next space is 60 squared, which is 3,600. So this symbol literally means 3,600 plus 21 times 60. 21 times 60 is, what is 21 times 60? My pen is really misbehaving today. That's going to be 1,260. And then 11. So this symbol would mean 4,871. That's what these 3 symbols would all represent together. Now that's just the introduction to the concept. Let's do some more concrete. So base 60 is also called sexagesimal. Each place value is a multiple of a power of 60. We can only use the symbols 1 through 59. So suppose this is a 12 and a 32 and a 41 and a 57. Using the symbols 1 through 59. Now this is the modern representation using Hindu Arabic numerals, just to give you the idea of how the powers of 60 work. So as we read from right to left, the first symbol means whatever it is. So 12 means 12. But 32 doesn't really mean 32. It actually means 32 times 60. And then you add these up from right to left. So when you get to the next one, 41, 41 means 41 times 60 squared. And finally, we probably won't get any larger than this, 57 times 60 cubed. This would be a huge number. It would be much larger than I can calculate in my head. If you're curious, I'll take out my calculator. Now you're just going to have to believe me because I can't show you the calculator using this application. But let's go ahead and do the largest one. So we have 60 cubed. 60 cubed is 216,000. And then we're going to multiply that by 57. So we're already getting astronomical values. That's 12 million and some change. The next one, 60 squared. 60 squared is 3,600. Multiply that times 41. And we get 147,600. The next one, 32 times 60. That's not so bad. You could probably do that in your head. That's 1,920. And then plus 12. So you would add up all of these numbers. 12,312,000 plus 147,600 plus 1,920 plus 12. So the number that I just illustrated in sexagesimal is 12,461,532. Maybe put some commas in there to make it easier to read. Okay. Now this is what we call the modern form of a sexagesimal number. In the Babylonian, each of these symbols, 1 through 59, is represented by the table that I'm going to show you in the next example. So example 6. Remember, we did 5 examples in part 1, so I'm picking up where we left off. Convert the Babylonian numerals into modern sexagesimal base 60 numerals. So really, this is just an exercise in finding the symbol on the chart. So this one looks like 11. And see if you can find that one in the chart. That one is 22. So this is your answer. Modern sexagesimal would be 11, 22. Now keep in mind, this is just a little mind cloud. You know how I like to do my mind clouds. 22 actually means 22, but the 11 does not actually mean 11. It actually means 11 times 60. So what does this number actually mean? Well, Using my calculator, 11 times 60, 660 plus 22. This number actually means 682. And I don't know what's going on with my pen today. It seems really sloppy, but we'll check in on that later. Okay, moving right along. Another example of just converting into the modern sexagesimal. So this is just finding the symbols. That one looks like 1. Oh. What is going on with my pen today? That's a 1. Let's see if we can find that mess. Where is that one? Right here. That's 47. This one looks like 46. And this one looks like it's hard to tell. We're not really experts in this. You can actually count the number of little triangle shapes. You get 1, 2, 3, 4. Looks like this one, 40. Okay. Now that is the answer, 1, 47, 46, 40. Keep in mind that if we were going to actually calculate what this number represents in Hindu-Arabic numerals, we'd have to multiply each successive term by a power of 60. I'll save that for the next example. Example 8. Convert the Babylonian numerals into Hindu-Arabic numerals. Well, first I'm going to turn them into modern sexagesimals. So find that symbol. That's a 10. This one looks like a 2. And this one looks like 13. Right, and then we read them from right to left. 13 does actually mean 13, but 2 does not really mean 2. 2 means 2 times 60, and 10 means 10 times 60 squared, or 10 times 3,600. So we have 36,000 plus 120 plus 13. So the final answer is 36,133. So this is the Babylonian number or numeral 36,133. Okay, we're getting close to the end here. Example 9, another reading example. The first 1, 2, 3, 4, 5 rows are just reading off the chart. So the first one, find it over here, looks like 3. And that really does mean 3. The next one, look for 3 of these sideways. They kind of look like arrowheads or spears. You have 3 of those, followed by a tower of 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So there it is. That is 35. Here we have one of these sideways little arrowheads, and it looks like 1, 2, 3, 4, 5, 6, 7, 8, 9. Stack of 9 with one sideways arrowhead right here. That is 19. There is a bit of a pattern here. It's not easy to see, but notice you don't start using the sideways arrowheads until you get to 10. And then 10 through 20, and then you start using 2, starting at 20, use 2 of those. So you can kind of tell what range it's going to be in by the number of sideways arrowheads. So this is going to be in the 40s. Or is it in the 50s? Let's see. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 2 of these. So that will be 42. You got to look very carefully at these. It's actually 4. 1, 2, 3, 4. 4 presses. Well, that makes sense. 40s are all 4 of the sideways ones. 50s are all 5 of the sideways ones. That's some method to the madness. This one is in the teens because it has 1 of the sideways. So we know it's in the teens, and then it has a tower of 5. So 1 with a tower of 5 would be 15. And if you grew up in Babylon, you'd have these memorized. All right, now they're going to get a lot tougher. You're probably going to need a calculator. So find out what this means. That looks like a tower of 5 or maybe 4, depending on how you're counting it. So that is 4. That's the number 4 right here. I guess 5 is easier to see because it has 2 points down at the bottom, and this only has 1 point down at the bottom. This is 1, 2, 3, 4, 5. So this number's in the 50s with a tower of 9. So that is 59. So that's 59. Now you're going to need to use your calculator. Remember that 59 does not really mean 59. It actually means 59 times 60. So you're going to do 59 times 60, 3,540 plus 4. So this number is 3,544. Just a couple more. So the next one, we have 2 sideways. That's 20. All right. Here we have 1, 2, 3, 4 sideways arrows. So that means we're in the 40s. And 1, 2, 3, 4. So that one is 44. Over here we have the Tower of Power. What's that going to be? That looks like a 7. Yeah, that's a 7. All right, now keep in mind 44 is actually 44 times 60, and 7 is 7 times 3,600. So we have 7 times 3,600. So this symbol here actually represents, oh man, my pen is really messing up on me, 25,200. Then we have 44 times 60. So we have 2,640 plus 25,200 plus 20. So finally we have 27,860. Last one. Looks like we're in the 30s. It has 3 sideways arrows and then 3 right side up arrows. So that'll be in the 30s. 33. 33. This looks like it's in the teens. It has 1 sideways arrow and 2 right side up arrows. So that's 12, or preteen. This is just 3 sideways arrows. So that represents 30. And then remember, 33 actually means 33. But 12 doesn't actually mean 12. 12 means 12 times 60. So this actually means 720. 30 doesn't actually mean 30. 30 means 30 times 3,600. So this is 108,000. So we have 108,000 plus 720 plus 33. Definitely going to want a calculator for these. I'm using one. 108,753. Finally, we're going to end this section with the Babylonian method for finding square roots. Suppose I wanted to find the square root of 40. Now remember, the Babylonians had no calculators, but they were very good at mathematics. They had some very sophisticated methods at the time. So using the modern algebraic methods, we're going to say let x equal 40, and we're going to start with a guess. We're going to guess a whole number that is close to the square root of 40. Square root of 36 is 6. Square root of 49 is 7. So our first guess is going to be 6. Yeah, we're a little bit closer to 36 than we are to 49. So whichever one is closer, that's what you want to start with. All right, so had we been 48, then I might have started with 7. So that's called our first estimate, R1. Then we're going to use the formula R2. R2 is R1 plus our original X divided by R1, all divided by 2. So R2 is going to be 6 plus 40 divided by 6, all divided by 2. That's called our second estimate. I'll do the calculation on the next page. We repeat this process as many times as needed. Each time you repeat, you're going to get closer and closer to the actual square root. Stop when you're satisfied with the answer or when the instructions tell you to stop. Okay, use the Babylonian method for finding the square roots. Find 3 estimates. R1. R1. R1 is a guess. We already guessed 60. Yeah, because the square root of 36 is 6. Did I say 60? You know what I meant. I meant 6. Square root of 36 is 6. So that's our first guess. You do have to know some basic square roots to get the process started. Now we're going to do R2, our second guess. That's going to be 6 plus 40 divided by 6, all divided by 2. That's 6 over 1 plus 40 divided by 6, all times 1/2. Let's multiply this by 6. So I've got 36 plus 40 divided by 6 times 1/2. 76 divided by 6 times 1/2. That'll be 38 divided by 6, or 19 over 3. Just FYI, what's 19 over 3? In case you're curious, 19 over 3 is 6 point something. .3. For our third estimate, we're going to take our previous estimate, 19 over 3, plus 40 over 19 over 3 divided by 2. That's going to be 19 over 3 plus 120 over 19, all times 1/2. Now we're going to need to find a least common denominator. So we're going to multiply this one by 19. We're going to multiply this one by 3. I'm going to need a little calculator help here. Can I get a little help here? A little assistance, please. 19 times 19 is 361. You all know what 3 times 19 is. You probably learned that in elementary school. That's 57. 120 times 3, that's 360. Also divided by 57, all times 1/2. So now I have 361 plus 360, 721 divided by 57 times 1/2 will be 721 divided by 114. And that's the answer. The Babylonian method for approximating square roots. It's actually a pretty good approximation if you use your calculator. I know the Babylonians didn't have a calculator, so it's kind of like cheating. But we've got one. This comes out to approximately 6.32. My pen is really bad today. I'm sorry about that. I'll try to look into that before the next lecture. That's 6.32. Just for fun, let's find the square root of 40. Hey, what do you know? The square root of 40 on a calculator is approximately 6.32 using a calculator. So the Babylonians were pretty darn good. That's only 3 estimates. 3 estimates, and we got pretty close to the value of 6.32. In fact, it's actually good to 3 decimal places. I checked on my calculator. It comes out to 6.324. Pretty darn good. Okay, that's the end of the historical math sections, 5.1 to 5.2. If you have any questions, you can email me or you can tune in for office hours at 12 o'clock today. Signing out.